slightly an important class in the sense we did a lot of applications with regarding to the decoders, right? Multiple simplification of decoders we saw. Every example was unique, right? So that you get any kind of examples or any kind of problems in your exam, you can simply apply these rules. We also saw what is an encoder, though there is no much to discuss about encoder, but there are certain problems with the encoders, right? So if two variables are one simultaneously, then what is the problem? And if nothing is on, then what will be the problem? We saw those examples and we touched upon multiplexer also. What is a multiplexer? It will have 2 power n number of inputs and 1 number of output. So where n will represent the number of select lines. We saw an example of a 2x1 multiplexer and 4x1 multiplexer towards the end of the last class. And we saw the truth table. So just to recall the truth table, this can be expressed as the Boolean expression. The output y here can be expressed as a Boolean expression here, that is I0 multiplied by S0 bar, S1 bar, likewise. So as written here. I think we ended our last class with this. Now today, which means the Boolean expression that you get will be an SOP expression. Okay. So now let us use the multiplexer to represent the Boolean expressions. Before that, let's take an example. You have to design a 4x1 multiplexer using 2x4 decoder. I mean, don't get yourself confused by looking the different blocks, a multiplexer block and a 2x4 decoder block. What is your objective? Your objective must look like this, which means I will have 4 inputs, 1 output, and then if I'm having 4 inputs, then how many select lines are required? I need 2 select lines. These are my inputs. This one is my output. Now I have to represent this as a 2x4 decoder. Now, how does a 2x4 decoder will look like? I will have 2 inputs and 4 outputs, right? So this is what is my 2x4 decoder is. And if this decoder, obviously most decoders will have additionally an enable signal, right? Now you compare this block and this block. Is there any similarity? Yes, there are similarities. What? These 4 outputs here are your 4 inputs here. 2 inputs here are your 2 select lines here. The enable signal is your output signal here. So this is the only difference here. Okay, so let us see how to design. Normally, yeah, we are going to use the same logic here. How is your multiplexer will look like? Multiplexer, if you forget about this particular block, just forget about this block here. Okay. Right. So this will be having what? A NOT gate, and then this again will have, I think it should, yeah, it should be a NOT here, and then these select lines. Yeah. So this will be say S1 and S0. So you can see that this particular line will be slightly different. Huh? Here there will be a NOT gate and there will not be any NOT gate here. Yeah. So actually there will be 2 inputs. There has to be 2 inputs here. Okay. So you know how a 4x1 multiplexer will look like. So this is how your 4x1 multiplexer will look like. So this is your select lines which I was trying to draw. But here, what is your objective? You have to design using a 2x4 decoder. What is the function of a decoder? That is, based on your 2 inputs, your 4 outputs are selected in a 2x4 decoder. Here we are having 2 inputs here. We have to select the 4 number of AND gates. We have to enable the 4 number of AND gates. So in order to do that, what you can do is, you can connect the 4 outputs of your decoder here, to enable the each AND gate, which means that when this is 0 0, then this 0 will be enabled, which means that this AND gate will be enabled. When it is 0 1, then this one will be enabled, this AND gate will be enabled, meaning your Y will have an output corresponding to I1. So which means I1 gets transferred to Y. Similarly, when this is 1 1, the last AND gate is selected and I3's input is transferred to Y. So this is how you implement a 4x1 multiplexer using 2x4 decoder. Instead of select lines, we are using the selection of AND gates through a decoder. Okay. Now, what is the application of this multiplexer? I've already said the applications of a multiplexer when we introduced the LSI circuits, like low scale integration circuits. When I listed down different applications, something like decoder, encoder, multiplexer, and demultiplexer. The trunk call example that I said you aptly very much it suits for the multiplexer and demultiplexer examples. So they are normally used in communication lines. So you have multiple n number of sources here and one output here, and to select the source, I said that this is the trunk call person who sits at the trunk office. Here also the select signal will decide the line to be connected to which destination. Similarly, if I am calling somebody, some one of my friends, say for example in England, then what happens is there will be multiple trunk offices where the connection gets through. So what I should do is I should just call this particular person and give me the number of my destination here, so that along with the code words they get connected. So this is the complete communication line that employs multiplexer and demultiplexer together. Okay, so this is a very simple example. Now let's again, the problem with the larger multiplexer remains as we saw it for a larger decoders. In case of, say for example, 4x32 decoder, is it 4x32? 2x4, 3x8, 4x16 decoder. Okay, so similar to 4x16 decoders, that is a larger decoder, we have a problem with larger multiplexers also, meaning that if I have say 8x1 multiplexer, then how does your circuit will look like? I'm just expanding this circuit. I will have 8 inputs, so which means I will have 8 gates here, and at the same time my select lines will be, I will have 3 select lines now, right? Because what is 8? What is 8? It is 2 power 3 is 8. So this 3 represents the number of select lines. So I will have S1, S0, S1 and S2. So each AND gate now will have 4 input AND gates. If I go in for a larger multiplexer, say for example 16x1, then I will have 5 input AND gates. Again, the problem will come in one single AND gate, one single IC. I will have AND gates with multiple number of inputs. So the fabrication will be very difficult. So it is always better idea. The problem same with the decoders. As we designed larger decoders with smaller decoders, here also we are going to design a larger multiplexer from a smaller multiplexers, which means the problem statement says implement 8x1 multiplexer from 4x1 multiplexers and 2x1 multiplexer, right? So this is clearly given to you. Now, what is the difference between the previous decoder examples and the multiplexer examples is, say you are trying to implement 4x16 decoder, right? So 4x16, how does it look like? 4 inputs and 16 outputs. This can be implemented using how many 2x4 decoder? I want 2x4 decoders. I will need 4 2x4 decoder, which means that I looked at the output section, right? For 4, so 4 multiplied by 4 4 multiplied by 4 was 16. So I looked at the output here. But whereas here, you have to look at the input side. Meaning, here you have to implement 8 cross 1 multiplexer. So you need 8 inputs. So the multiplexer that you are going to, the smaller multiplexer that you are going to use will be 4 cross 1 multiplexers, right? 2 4s are 8, right? So hence you have to look at the input side in multiplexer. You have to look at the output side in decoders. So let us look how to implement this. Let's look at the example. Okay, now what is an 8 cross 1 multiplexer? It will have 8 inputs, I0 to I7. And it will have how many select lines? What is 8? 2 power 3 is 8, which means that 3 select lines will be there. 3 select lines. What are the select lines? S0, S1, S2 will be the select lines. And your one output. So this is nothing but your 8 cross 1 multiplexer. Now if I want to implement using 4 cross 1 multiplexer, I just explained that you will require 2 4 cross 1 multiplexers. So how does it look like? A 2 4 cross 1 multiplexer means I'm just drawing the block so that you can visualize it better. I'm going to have 2 4 cross 1 multiplexer. When I have 4 cross 1, one output, 4 inputs. So my first 4 inputs are taken care of. Then next 4 inputs will be taken care by the next 4 inputs of my second multiplexer. This is my first multiplexer. This is my second multiplexer, and I will have another output. Please see here that I am having 2 outputs now, but in my final multiplexer, I am having only one output. So in order to select this also, I should use a 2 cross 1 multiplexer. 2 cross 1 multiplexer. Okay, and how do I decide this 2 cross 1 multiplexer? So I need 2 4 cross 1 multiplexer. So this will be the input to the next stage, hence 2 cross 1 multiplexer. Let me quickly uh, take another problem. Okay, anyway, I'll explain this particular part again so that you get similar to as we did in the decoder part. You got familiarized with how to select the number of decoders. I'm just going to give you some random problem. Say for example, I want to implement 32 cross 1 multiplexer using 4 cross 1 multiplexer. Okay, so this is the problem statement. Now, first, how many 4 cross 1 multiplexers you want? You will require 4 8s or 32, right? So I will need 8 number of 4 cross 1 multiplexer. Now, if I have 8 number of 4 cross 1 multiplexer, then on the second stage, what kind of multiplexer I would like? I will have 8 outputs coming. So I will be needing 8 cross 1 multiplexer, but I should not use this 8 cross 1 because there's a larger multiplexer. Instead, I can use 4 cross 1 multiplexers. How many 4 cross 1 multiplexers? I need 2 4 cross 1 multiplexer. So I have, maybe I'll use notes. Huh? Sorry, something else up there. Yeah, this is your page. Okay, so let me write clearly here. I need to design 32 cross 1 mux using 4 cross 1 mux. Mux means multiplexer. So how many 4 cross 1 mux? Right? How many 4 cross 1 mux? 4 8s are 32. So I need 8 numbers. So even do not decide at the start of your designing itself that how many 4 cross 1, 2 cross 1 multiplexers are required. No need to design at the start of the problem. Just immediately you require 8 4x1 multiplexer. So what you do is first draw 8 4x1 multiplexer. 1, 2, 3. I'm not going to draw all the 8s. Assume that it is 8, right? So which means I will have 4 inputs here. Next to 4, that is 8. So this will be 4. This will be additional 4, that is 0 to 3 amp in fact. So 4 to 7, which means 4 inputs. Next 8 inputs. Likewise till 32 inputs, I will be having 8 multiplexers, right? So I will be having 8 output lines here. I will be having 8 output lines, right? So 8 output lines I'm going to get. So I'm not going to use a 8x1 multiplexer to select this. Instead, what I'm going to do is I'm going to use a 4x1 multiplexer, which means that for the first 4 outputs that are coming, I will use one 4x1, and for the next 4, I will be using another second 4x1. Again, 2 outputs will be coming. So in order to select this, I will use a 2x1 multiplexer and one output will be there. Okay, so how many 4x1 multiplexer instead of 8? I might go wrong, right? So that is why I asked, don't decide at the starting itself how many 4x1 multiplexers. I will be able to design this using 10 4x1 multiplexers and one 2x1 multiplexer. This is how you design larger multiplexers from smaller multiplexers. Any doubts here? Okay, now let's proceed. Let's come back to this problem. Yes, this requires slight understanding. I hope today's class will be slightly shorter because we will be completing combinational circuit and then we will be moving to sequential circuits. Sequentials again circuits require some fresh mind, and hence I don't want to touch after half an hour of the class. Okay. So now let me explain how this works. 8x1 multiplexer using 4x1 and 2x1 multiplexer. As I said, these 8 inputs now will get split to I0 to I3, right? So 4 inputs here and 4 inputs here. This is a 4x1 multiplexer. To select this 4x1 multiplexer, to select these inputs, I will have S0 and S1 as my select signal, right? So there are certain things that you need to observe, slightly be careful, right? Always this select signal will be same for all the multiplexers you are selecting. Now go to the larger picture. If you look at the larger picture, to select these 8 lines, you used 3 select lines, right? Always from the LSB, that is S0 and S1 will be used to select the first stage. Why? Because these inputs we can write it as how? 0, 0, 0, 0, 0, 1, 0, 1, 0, likewise till 1, 1, 1. So when I say the select lines, so these two corresponds to the LSB bits, right? So hence S0 and S1 corresponds to the first stage of my multiplexer select lines. Now here I will be having my outputs. Okay, an example has been taken. Don't worry about it. So I am going to have an output and the leftover select line, which is S2, will be used to select my second stage of my multiplexer, which is 2x1 multiplexer. Now, how does this multiplexer works? Now, say I want to transfer, though this is the truth table, say I want my input across 5 to be available across my output, which means that I want this I5 input to be available across my output. If I5 must be available, what must be the select signal I must give? I must give 101 as my select signal. Am I right? So if this is 101, my S1, S0 and S2 corresponds to this. So S1 and S0 corresponds to 0, 1. So I will have 0 and 1 here. When it is 0 and 1, please note that here also this I1 will be selected and here I5 will be selected. Both the inputs are selected. That is the second input of my multiplexers are selected. So along this line, I will have, don't look at this. This is another example that I have taken. I will have I1 as my output available here, and I will have I5 as my output available here. Now here S2 corresponds to what? S2 corresponds to 1. Since here S2 corresponds to 1, this input corresponds to 0, this input corresponds to 1. So this input is transferred to my Y here. So, and my Y will have an output I5. Understood how this works? Okay, I'll take another example. Okay, I'll take another example that is written here. Say my select line is 100. Okay, my select line now, I want to select this one, 100. So S1 and S0 corresponds to 00, right? So 00 means across output of first 4 plus 1 multiplexer, I will have I0 available here. I0 is available. Across this, the first input is I4, so I4 is available. So, and S2 corresponds to what? S2 corresponds to 1 here. When it is 1, this is 0, this is 1. So I4 will be transferred to Y. This is how it works. If this is 0, 0, 0, this is 0, 0, 0, then I0 gets transferred to Y. So this is how the simple multiplexer works. Now, another example here. Use 32 cross 1 multiplexer using 16 cross 1 multiplexer. So 16 cross 1 means 2 6 are 16, right? So I will need two 16 cross 1 multiplexer. And how many outputs will be? When I have two 16 cross 1 multiplexer, I will have two outputs. For the second stage, how many multiplexer I will require? I will require 2 cross 1 multiplexer for my second stage. So hence a hint has been given, use 2 cross 1 multiplexer also. So if it is 32 cross 1 multiplexer, my inputs will range from 0 to 31. So when I divide this by 2, I will have inputs, one multiplexer will have inputs from 0 to 15, and my second multiplexer will have inputs from 16 to 31. That's what is written here, 0 to 15 and 16 to 31. And how many select lines? What is 2 power, 32 corresponds to 2 power what? It is 2 power 5. Am I right? So 2 power 5 is, am I right? 2, 4, 6, 8, 16, 32. Okay, so 2 power 5. So 5 select lines will be there. So for 2 cross 1 select, for 2 cross 1, which how many select lines I will require? I will need one select line, which will be my MSB bit A. Okay, and my other select lines, let us assume that A, B, C, D, E are my select lines. B, C, D, E will be used to select the 4 cross 1, 16 cross 1 multiplexers here. So this is how you implement a 32 cross 1 multiplexer from 16 cross 1 multiplexer. Any doubts? Okay. Now, how do you implement a Boolean function? Why we are interested in Boolean function? Because if you remember, we started off implementing the Boolean function using decoder. Say you want to implement sum of 0, 1, 5, 6. Then how did you implement it using a decoder? The decoder that I would like to have will be how many? 2 cross 8 decoder, right? 2 cross 8 decoder. Sorry, 3 cross 8 decoder. Yeah. So 3 inputs will be there and 8 outputs will be there. And so 0 line, 1 line, 5th line and 6th line will be ordered together to get this function. This is how I implemented a Boolean expression using decoder. Similarly, how do you do that using a multiplexer? Now here, the select lines will play an important role. So let us jump directly to the example. If say for example, okay, it's better to have. So if we have a Boolean function of n plus 1 variables, okay, so here how many variables are there? maximum allowed variables will be, okay, so here the function has got 3 variables. So here n plus 1 is equal to 3, which means that n is equal to 2. And the number of select lines, number of input will be based on this only. Let us take n of these variables and connect them to the select lines. So this will be the number of select lines. Yeah. Remaining single variable of the function is used for inputs of a multiplexer. So any n plus 1 function can be generated with 2 n plus 1 multiplexer. Okay. If you don't understand, never mind. I'll just explain you here. What do they say here is, if say for example, let's take the example, that's why I said, if you want to implement this Boolean function, how many variables are there? 3 variables are there. So n plus 1 is equal to 3, which means that, which makes n equal to 2. If n is 2, then the number of input combinations will be 2 power n is to 1. So you require a 4 cross 1 multiplexer. What do they say here is, use out of these 4 inputs, use one input as a select line and use one input as an input line and use the remaining 3 as a select lines. That's what they say. Let us take an example, then you will understand. Now what is that we are going to do here is, out of these 3 variables, I'm going to use, it should not be 3, right? It should be 2. 2 plus 1 is 3. Yeah. So, okay, in case I confused you, forget about this. Okay. Now, out of these 3 variables, 2 I'm going to use it as a select line and 1 I'm going to use it as a input line. So I have A, B and C as 3 variables. These 2 variables I will use it as a select line. Please remember the multiplexer diagram. It will look 2 select lines, if it is 2 select lines, 4 inputs and one output. So this will be 4 cross 1 multiplexer. So our 2 variables will be used as a select line, and out of this 4, A will be used as an input line, a combination of A. What are the combinations of A? A can be either just A, or it can be A bar, or it can be 0, or it can be 1. So all these 4 will be the inputs of my multiplexer. Okay. Now first let us express this function as a truth table, then you will understand. What are the min terms? Min terms are 0, 1, 2, 3, 4, 5, 6, 7, and the variables are A, B, C starting from 0, 0, 0 to 1, 1, 1. And what are the function min term values? 1, 3, 5, 6. You see here that 1, this corresponds to 1, 3, 5 and 6. They will have 1 here. They will have 1 here. Now how do you implement it? Please remember that A is your input. So we are going to create an implementation table. Please listen carefully. What is an implementation table is? That is, on your left hand side, the first column, you will write the input variables options. So what is your input variable? A is your input variable, and A can be either, they can be A bar or they can be A. A bar corresponding to 0 and A corresponding to 1. Why did we do this? Why did we do this is, look at the truth table and look at the A column here. A has got series of zeros and A has got series of ones. So hence this corresponds to A bar and this corresponds to A. Hence our first column consists of A bar and A. And the column wise, we are going to implement it using which multiplexer. That is why we first itself we decided that this will be implemented using a 4 cross 1 multiplexer. If it is 4 cross 1 multiplexer, from the manufacturer I will have my inputs I0, I1, I2 and I3 here. So my inputs will be I0, I1, I2 and I3. Okay, please again remember that this I0, I1, I2, I3 will be selected by my select lines B and C. So BC can take values 0, 0, 0, 1, 1, 0, 1, 1, right? Look at the truth table also. 0, 0, 0, 1, 1, 0, 1, 1. The same thing repeats here also. 0, 0, 0, 1, 1, 0, 1, 1. So just list down the mean terms. A bar corresponds to 0 and 0, 0 corresponds to I0 corresponds to 0, 0, right? So 0, 0, 0 corresponds to 0. Just write the min terms here. I1 corresponds to 0, 1. So 0, 0, 1 corresponds to 1. Don't look at the circle here. I'll explain now. I2 corresponds to 1, 0. So 0, 1, 0 corresponds to 2. I3 corresponds to 1, 1. And here no need to write in grayscale. Just you can just list down. So 0, 1, 1 corresponds to 3. And A4, this corresponds to, A corresponds to 1, 1, 0, 0 is 4, 1, 0, 1 is 5, 1, 1, 0 is 6, and 1, 1, 1 is 7, right? So you have listed down the min-term numbers. Now what is the rule? Okay, now what is the rule here? Now what is your required given function now? Your given function is 1356, right? Just circle all those particular functions here. It is 1356. So circle 1, circle 3, circle 5, and circle 6. Now across a column, if you don't find any circle, put 0. Across a column, if you find two circles or if all the circles are filled, you put 1 here. If there is only one circle, look at the corresponding A value. If it is A on A row, then write A. If the circle corresponds to A bar row, then write A bar, right? So I hope, is there any doubt till this? Okay. Now what you do is, we are ready to draw the implementation diagram. So this has been, the rules has been listed down here. Anyway, when I give you the notes, you will understand. Now the implementation part. Now we know, let me draw here instead of jumping. So what will be my 4x1 multiplexer will look like, because I'm going to implement it using a 4x1 multiplexer. I've already decided this. So I'm going to have 4x1. So my inputs are going to be I0, I1, I2, I3. And my select lines are going to be S1, S0. And my output is going to be Y. So I0, I1, I2, and I3, my select lines. Now the problem variables. What are my problem variables? My problem variables are, okay, I0, I1 is already there. What are my select lines? My select lines corresponds to B and C, and my input lines corresponds to A. Now I0 corresponds to what? 0. So what you do is, this I0 line corresponds to 0. So you ground it, or you put a 0 value here. I1 corresponds to 1. So what you do is, you put 1 here. I2 corresponds to A. So just connect A here. I3 corresponds to A bar. So if this is A bar will be a knot of this. Am I right? So this will become A bar. So that's all. This is how you implement. So you get your output. So a 4x1 multiplexer. So this one will implement the given required function. Say for example, it is 1356 only, right? So if it is 1356, say let us assume that I am going to give an input of 110. I'm going to give an input of 110. So BC corresponds to 10 and A corresponds to 1. Let us see if it works or not. It has to be 1. 110 means you have to have 1 across this here. If this is 10, what will be my select lines? 10 corresponds to I1. So what is I1 is having? I1 is having 1 here. So output will be 1. We want to take another example. Let us take 0, 1 here. Okay. So 0, 0, 1. BC corresponds to 0, 1, right? So 0, 1. 0, 1 corresponds to, okay. Did I do a mistake? Yes, I think in the previous example I did a mistake. That is, if it is 1, 0, if it is 1, 0, we want 110 only, right? If it is 10, then I2 is selected. So A will be the output here. So A, what is A value? A value, what is A value here? It is 1 here. So you get an 1 at the output. Okay. So likewise, you analyze the multiplexer circuit. Let's take another example. The same thing. Now, immediately a question will come. Is it always required to select only the MSB as your select lines? No. You can select any of the listed variables as your select line. In another example I have taken, out of the three variables A, B, C, I'm going to select AB as my select line and C as my input line. Okay, so which means that my input variable will be C bar and C, and my select lines will be AB. Now you have to look very carefully right here the truth table. AB is 0, 0. AB 0, 0 means the first cell C is also 0. So my first cell will be 0 here. Now next truth table, 0, 0 for AB correspond and C is 1 here. So this is 0, 0 and C is 1. So 1 will come here. Similarly, 0, 1, 1, 0 and 1, 1. You have to first write the minterms correctly. So once you write the minterm, again you see here that I'm having 1 across the C. So I will write C here. Again, there is only one circle corresponding to the Cth row. So C is written. The last column has got a circle corresponding to C bar. So C bar is there. Now, how do I implement a 4x1 multiplexer? Please look at the variables that are written inside. The variables that are written inside are manufacturer variables. So your select lines are going to be A and B, and your C is going to be your input. So I0 will have C. I0 has got C. I1 has got C. I2 has got C. I3 has got C bar. So a C bar has been placed across this, and Y will be your output. So this will be your function f of A, B, C. Any doubt here in implementation? I thought I will complete this early, but still I can't do. Okay. So next, let us quickly look at another example. How many variables are there? 4 variables. So which means n plus 1 is 4. So 3 plus 1 should be 4, which means that there will be 3 select lines. Before that, I have to identify the kind of multiplexer. So what is 2 power 3? It will be 8. So the multiplexer I will be using will be 8 cross 1 multiplexer. Again, there will be 1 select lines and 3 variable lines. Okay, so there will be 3 select lines and 1 input line. Always input is going to be 1 only. So I have selected out of A, B, C, D. I have selected this to be input and this to be my select lines. So A bar and A will be my input lines and these will be my select lines. So just to fill the table, 0, 1, 3, 4, 8, 9, 15. So circle all those things 0, 1, 3, 4, 8, 9, 15 and circle it around. So you have 2 circles here. So 1, 2 circles here, 1, no circle here, hence 0. A circle corresponds to A bar. A circle corresponds to A bar. No circles here, so 0. So 15 corresponds to a circle corresponds to A. Now, how do you implement? Please note you are going to use an 8 cross 1 multiplexer. So in 8 cross 1 multiplexer, my select lines are going to be B, C, D. So I0 and I1 has got 1. I0 and I1 has got 1. I2 has got 0 and I5 and I6 also has got zeros. And I3 and I4 has got A bar. So A bar has been connected to I3 and I4 and I7 has got A. So this is the simple implementation of a 8 cross 1 multiplexer of a Boolean expression. Let's take another example quickly. So there are 4 variables here. So n plus 1 is 4. So only possibility is 3 plus 1 is 4. So what is 2 power 3? It is 8. So I require 8 cross 1 multiplexer. Out of these, I can use D as my input and ABC as my select lines. So if D is your input, please remember that this corresponds to 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Now, how do you find out the cell value here? This is 0, 0, 0, 0. So this cell corresponds to 0, 0, 0, 0. Maybe randomly I will take this particular cell. This cell corresponds to 1, 0, 0 and D is 1 here. So 1, 0, 0, 1. 1, 0, 0, 1 corresponds to 9. This cell let me take. It is 1, 1, 1, 0. D bar is 0. So 1, 1, 1, 0 corresponds to 14. Right? So I have made. Now let me circle it. 1 is circled, 3 is circled, 4 is circled, 11 is circled, 12 is also circled. 12 should be circled. Okay, that is a mistake then. 12 is circled, 13 is circled, 14 is circled, and 15 is circled. So now this is an 8x1 multiplexer. So I have only one circle corresponding to D. So it is D. It is D here, D bar here, 0, 0, D here. It should be 1 and 1 here. So accordingly connect these input lines. And these are, since I didn't have space on this page, I have written my select lines like this. Otherwise, this is your output. Okay. Any doubt here? Okay. Next is a demultiplexer. What is a demultiplexer is? It will have one input and many outputs. Okay. So, and you will have select lines here. These select lines will decide where your input will go to which output line, which means that I can always write my output, say y1, to be equal to this D multiplied by the select lines. So y0 can be written as D, because this is the first line corresponding to 0, 0, which means that D S1, S1 bar, S0 bar. Y1 corresponds to D S1 bar, S0. And y3 corresponds to D S1 S0 bar, and y4 corresponds to D S1 S0, because this is 0 1 1 0 and 1 1. 1 1 corresponds to S1 S0, hence these are the Boolean functions. Now if you look at the truth table, this is a 1x4 demultiplexer, and if it is 1x4 demultiplexer, what power of 2 is 4? It is 2 power 2 is 4. So the number of select lines will be 2. So this is how you find out. So number of select lines are 2, and your outputs will correspond to, when your input is, your select line is 0 0, your first output line will get the data. When it is 1 0 1, your second output line will get the data. When it is third output line will get the data, and when it is fourth output line will get the data. Right? So normally this demultiplexer, you can always visualize it like a decoder, right? You remember this is an 4 output line and 2 select line, and you can relate always this to a 2x4 decoder with an enable signal. So assume that this is an enable signal, this is your input and this is your outputs. So this can always, you can write your demultiplexer as a decoder with an enable signal, which I just mentioned. Your select lines will be the inputs, 2x4 decoder. The Boolean expressions are almost similar to the demultiplexer. So with this, we complete the combinational circuits. So any doubts till this? Not much of a problems or examples with the demultiplexer. A lot of problems only with multiplexers and in fact decoders, not even with the encoders. So from next class, it requires really a fresh mind to understand the sequential circuits. So from Monday, let's start afresh on sequential circuits. Any doubts? Okay. So thank you so much, and then we will start sequential circuits from Monday. So suddenly, if you look, we just have 4 weeks of our class, right? Not even 4 weeks, I believe. So 4 3s are 12 classes alone. So I have a lot to cover. That's why I'm very, very slow because of this online thing. Okay, good. So thank you. Let's see on Monday.